we have a concrete idea of how the universe unfolded from an original singularity 13.8 billion years ago and how the first stars, galaxies, and black holes were formed. But what actually happened before the Big Bang? Well, Stephen Hawking answered this question with a decisive nothing, as time itself only began with the birth of the cosmos. However, some researchers have a slightly different view in this regard. According to them, the Big Bang was by no means the beginning of everything but merely one of countless Big Bangs that are still occurring to this day. This also means that our universe is not the big picture but merely a tiny link in an infinite chain of universes. Is there any real evidence that makes this assumption more than just an exciting theory? Actually, there is. The James Webb telescope has recently recorded a discovery that suggests the almost unbelievable conclusion that our world is currently merging with other universes. When astronomers in the 1920s began to study distant galaxies, they came across something unexpected. They realized that most galaxies were moving away from us. This finding fueled speculation that Earth could be at the center of the universe. However, experts soon realized this was not the case. Further observation showed that not all structures are involved in this galactic mass exodus. In fact, the Milky Way and the Andromeda Galaxy are moving toward each other and are expected to merge in just over 3 billion years, according to our current knowledge. Around 100 years ago, the movement of galaxies seemed like an unsolvable mystery. But after decades of detailed investigations, experts discovered the true reasons behind these galaxy movements. We now know that, strictly speaking, it's not the galaxies moving through space, it's space itself that is constantly expanding. The expansion of the cosmos, however, is not as simple as it might seem. It has no central starting point, meaning that everywhere in the universe it appears as if other entities are moving away from you. Regardless of where you observe from, it would always seem like you are at the center of the universe, with everything else fleeing. This finding also provided another important piece of information: the universe itself does not have a fixed center, and everything is moving away from everything else due to cosmic expansion. Moreover, scientists have discovered that space is not only expanding, but the rate of expansion is actually increasing. In other words, the farther away a galaxy is from us, the faster it is moving away. Faster it is moving away from us. In fact, recent studies have shown that 97% of galaxies in the observable universe are actually moving away from us at faster than light speed. But how is this even possible? Doesn't this stand in stark contradiction to Einstein's theory, which states that nothing is faster than light? Well, not really. In fact, Einstein's theory only applies in empty space itself. The galaxies, in reality, are at rest in space, and their movement is based on the expansion of space itself. As mentioned above, no cosmic speed limit is broken here. Incidentally, it was even Einstein himself who recognized that such faster-than-light speed is possible within the limits of space. The confusing background to the Big Bang: astronomers generally assume that cosmic expansion began with the Big Bang. This is hardly surprising, as space was formed together with matter and time from an original singularity. And how could something that did not yet exist have expanded beforehand? As the often cited beginning of everything, we often imagine the Big Bang as a brute event in which the cosmos literally exploded into existence. According to this, the origin of everything that once existed, exists today, and will exist in the future, lay dormant 13.8 billion years ago in an unimaginably hot, dense point. Now, one could imagine the corresponding singularity as a tiny dot in the proverbial void. But how does this fit in with the assumption that the universe is infinite? In this regard, some experts point out that the cosmos must have always been infinite, even if it is today. Or, to put it another way, the Big Bang did not happen at a specific point but everywhere. This also means that the first galaxies did not form in a specific region of space, but everywhere in the universe. In the same breath, it appears that matter also appeared everywhere in the cosmos at a certain point in time. Despite all this, the common picture of the Big Bang still leaves some crucial questions unanswered. After all, what actually caused something to suddenly appear out of nothing 13.8 billion years ago? How can something come out of nothing at all? And was there a trigger, or was it pure coincidence? Well, we simply don't know the clear answers to these profound questions, and they have always been hotly debated among experts. The bottom line is that the Big Bang theory alone is not capable of explaining all the characteristics of the universe that we can observe today. These include, for example, the isotropy of the universe, or in other words, the fact that it always presents itself to the observer in the same way, regardless of the observer's direction of observation and in space. And this is where cosmic inflation finally comes into play. This is a phase of extremely rapid expansion of the universe, which is thought to have immediately followed the Big Bang, transformed from something tiny into something significantly larger in less than a trillionth of a second. But what was the engine that drove this elemental process? Well, researchers point to a mysterious force that is still said to be driving the accelerated expansion of the universe, whose background is largely unexplained: dark energy. Webb's mysterious discovery fuels an incredible theory. At this point, however, it should be noted that although dark energy and the associated fields are a possible cause of the ignition of cosmic inflation, we do not know whether there really is a connection between the dark energy of that time and the dark energy of today. As mentioned, dark energy is considered in current space research to be the driving force behind the accelerated expansion of the universe. However, although this mysterious form of energy has had a firm place in the world of astronomical research for over 25 years, its actual existence has still not been proven experimentally. Against this background, some scientists believe it is conceivable that it's not actually dark energy driving the accelerated cosmic expansion, but something we otherwise only know from crazy science fiction films. Unbelievable but true, a study published on December 12, 2023, in the Journal of Cosmology and Astroparticle Physics actually concludes that what our instruments perceive as the expansion of the universe could actually be the result of universe mergers. In order to understand the background to this unconventional assumption, however, we first need to take a brief detour into the world of the Hubble constant. Basically, it indicates how fast the universe is currently expanding, but unfortunately, it also embodies a gigantic puzzle in the same breath. Because if we determine the Hubble constant on the basis of cosmic background radiation, we obtain a value of 67 km per second per megaparsec. However, as soon as experts take supernovae, red giants, gravitational lenses, and variable stars, so-called Cepheids, into account, the Hubble constant is suddenly 73 km per second per megaparsec. In other words, the universe is expanding much faster than it should be. But how can that be? After all, according to our theories, space should be expanding at the same rate everywhere. Well, one possible explanation is that the measurement results of the past were clouded by errors and inaccuracies. To find out whether this is really the case, the James Webb Telescope recently took a close look at 320 Cepheids and delivered the sobering but clear finding that the previously observed deviations are in line with reality. So, the discrepancy of the Hubble constant is real, but how can it be? Adam Rees, a Nobel laureate in physics and the lead author of the study, explains that we may have misunderstood the universe. In other words, there could be forces and processes out there that we have simply not taken into account in the standard cosmological model. This could include an exotic form of dark matter or dark energy, but it could be even more groundbreaking. Has our universe been swallowed up by another? Jan Amborn from the University of Copenhagen believes it's more advisable to leave dark energy behind when it comes to the Hubble discrepancy and instead consider the possibility that our world is currently merging with other universes, and not just since yesterday. The real reason for cosmological inflation, according to Amborn, is that our young cosmos was once swallowed up by a larger parent universe, and since then, our universe has been doing the same to its mother world. After it was absorbed, it collided with other baby universes to ultimately absorb them as well. But how did researchers even come up with such an idea? By working out a mathematical model that examines the effects that several interacting universes could have on our cosmos. The experts' calculation showed that the merging of worlds would increase the volume of our universe, an increase in volume that our measuring instruments interpret as an expansion of the universe. But that's not all. At the same time, researchers also determined the rate of expansion of the universe that would be expected in such a scenario, and the corresponding results agreed even better with space observations than the traditional standard cosmological model. However, even the most breathtaking theory can only be confirmed by real observational data. But how do you observe a different cosmos in the first place? Well, not at all. To test the hypothesis of the merger of universes, experts are currently conducting numerous experiments to investigate the microwave background. This radiation relic from the time shortly after the Big Bang could hold unknown characteristics that may one day bridge the gap to other worlds. And if you want to build a bridge to our videos on a regular basis, be sure to click the thumbs up and subscribe button. Join our community and stay up to date. We'll see you soon.